Today we're going to learn how to solve a quadratic equation by completing the square. Basically, completing the square is a fancy version of the square root method that we just did in class. So we're taking something that wouldn't usually be the square root method and forcing it to become a square root method problem. So if you remember about square root method, we couldn't have an x term in my square root method. So these problems would usually not be able to be using it. So what we're going to do is force it to look like one of the problems we've done before. And to do that, when I'm completing the square, one way you can remember this is A, B, C, and we're completing the square. So when I'm completing the square, I want my equation to be equal to C. This is different than when I was solving by factoring. So I'm going to move that negative 24 over and make a positive 24. Now what I'm going to do is I really want the left side to become a square. We're going to draw a literal square. Our box. We put our first term in the first box, but before you say last term, last box, we're actually not going to do that this time. We're going to take our middle term and we're going to split it in half, because when I split something in half, then those are going to be two equal parts. And now I'm going to think about factoring like I usually would. So usually I would get x, 5, and 5. So that's in my box would be x plus 5 times x plus 5. And a short way to write that is x plus 5 squared. But notice I have this missing square right here. It's literally that we need to complete this square, because what I have written so far is equivalent to x squared plus 10x, but I need to add something in to make this perfect square. And what I would do is I would multiply 5 times 5 and get 25. Do you see 25 on this side originally? No. So what I'm really doing is adding in or completing this square. But if I add something on the left side, that means I need to add it on the right side. So whatever I fill, I call it the gaping hole. Whatever I fill the gaping hole with there, I need to fill it in on the right-hand side too. So that's going to give me 24 plus 25 is 49. And now these are like the more challenging square root method we did before. So we do the square root of both sides. Don't forget your plus or minus. So x plus 5 equals plus or minus. I can simplify square root of minus 7 and subtract the 5 over. So that will give me x equals negative 5 plus or minus 7. And I can combine these. So I'm going to do negative 5 plus 7 is 2, and negative 5 minus 7 is negative 12. So looking at the next one, if I want to solve by completing the square, we're going to move our c term. So I'm going to add the 17 to both sides. X squared plus 16x equals 17. Now I'm going to draw my box. I always put the x squared in top, and it should, for these, it should always just be x squared. Then I'm going to split 16x in half, so that would be 8x, 8x. I factor it out like normal. X, 8, 8, which means that I can write the outsides of my box as x plus 8 squared. But I need to fill in my extra part of my square. 8 times 8 would be 64. So if I'm adding 64 there, I need to add it on the right-hand side. And that's going to give me 81. Now it's a normal square root problem. Take the square root of both sides. Don't forget the plus or minus. So x plus 8 equals plus or minus 9. And then we'll subtract 8 from both sides. So x equals negative 8 plus or minus 9. So x equals negative 8 plus 9 is 1. Negative 8 minus 9 is negative 17. I want you to pause and see how far you can get with this next one. X squared plus 10x plus 28 equals 0. When you think you've done it, then I want you to press So we're going to subtract 28 from both sides, because for completing the square I need it equal to c. So everything with an x is on the left, and everything that's just a constant is on the right. Now draw our box. First term, first box. And we're going to split 10x in half. So 5x, 5x. Factor it out. Now we're going to factor that out. So we have x, 5, 5. So I can rewrite that as x plus 5 squared. But I have this missing piece, which is going to be 5 times 5, 25. So I need to add that on the right-hand side. So I'm going to get that equals negative 28 plus 25, negative 3. And now we're going to do plus or minus the square root of both sides. So my left side reduces to x plus 5 equals plus or minus. I can't simplify the square root of 3, but since it is a negative, I'm going to take that out and make it an I. And then my last step is going to be to minus 5 both sides. X equals negative 5 plus or minus square root of 3i. Since I have a square root or an imaginary number, I have both in this case, with the second term, I can't combine those, so done. At the next one. If you want to pause it and try it and then check, that would be great. So I'm going to add 36. So x squared minus 2x equals 36. Draw your box. First term, first box. Since I'm completing the square, I'm going to split that term in half. So negative 1x, negative 1x. Factor it out. X, negative 1, negative 1. So the outsides of my box are x minus 1 squared. Fill in your gaping hole. Negative 1 times negative 1 is positive 1. So I need to add 1 to both sides. 36 plus 1 is 37. Now we're going to do the square root. Don't forget plus or minus. X minus 1 equals plus or minus. I can't do anything with 37. So square root of 37. And then add 1 to both sides. So x equals 1 plus or minus the square root of 37. What is different about these next ones? They have a coefficient. So when we have a coefficient and we're completing this square, I'm going to need to get rid of that coefficient. But before I worry about that, I still need to think of my constants on the right side. So I'm still going to add 3 as my first. Whoops. So I'm going to add 3, which is 2x squared minus 12x equals negative 16. And we do that because a lot of times it helps prevent me getting fractions or more fractions. Now what you do, you're going to divide everything by what's in front of the x squared, even if it doesn't divide evenly into everything. So it's not that it's a GCF. That's whatever is in front of x squared. So I'm going to reduce to x squared minus 6x equals negative 8. And now it's the same type of process. So draw your square. X squared goes in the top. Split the negative 6x in half. Factor it out. And then negative 3, negative 3. X minus 3. Negative 3 times negative 3 would be 9. So plus 9 equals negative 8 plus 9 would be 1. Do the square root of both sides. Don't forget your plus and minus. X minus 3 equals plus or minus 1. Add 3 to both sides. So x equals 3 plus or minus 1, which will reduce to 3 plus 1 is 4, 3 minus 1 is 2. So I want you to pause and try the next one on your own. Subtract 1. (16 minus 1 is 15). Now I'm in front of my x squared. I'm nice and make these turn out well, but like I said, you could have done this and it be fractions. It's still your step. Negative 18 divided by 3 is 6. And 15 divided by 3 is 5. And the same process. Negative 6x split in half is negative 3x. Negative 3x. Factor it out. X, negative 3, negative 3. So I'm going to rewrite that as x minus 3 squared. Negative 3 times negative 3 is